Okay, so we're going to do some of these more complex trigonometric questions today, and I'll just run through the examples that are found on the sample quiz so you can get the idea of how they're done. This first one is angle theta is in quadrant, oops, I didn't write the quadrant 3, and sine of theta is negative 0.5. Find possible coordinates that lie on its terminal side of the angle. So first of all, we have to notice that the given information tells us that the angle is in quadrant 3. Okay, so this would be our angle theta. I also know that the sine of it is negative 1/2. I converted the 0.5 into a fraction. I did that because I know that the sine of an angle is equal to the opposite side over the adjacent, or the also we could use the y coordinate over the, sorry, not I said opposite over adjacent. What I meant is opposite over hypotenuse, or the opposite side over the radius, or the y coordinate over the radius. This is a formula from last week. Okay, and so what we're trying to find is a point on here, and a point on the angle is going to have the following, because we already know that the y coordinate can be 1 and the radius can be 2 here. Okay, and so if I know that my y coordinate is 1, but wait a minute though, because this is in the y, my y coordinate, it's going to have to be a negative 1 because it's down below here. Remember that the y points are negative down below here. So I already know that I could have a 1 right here, and I know that this distance is 1, and I know that that distance is 2, because the radius is 2 and the y coordinate is 1, and it actually is going to be a negative 1, and that makes sense because it's a negative 1/2. So therefore the y coordinate would be negative 1 and the radius is 2. Negative 1 divided by 2 is a negative 1/2, or a negative 0.5. There's a street sweeper. I'm going to close the window. Okay, so but we need a possible coordinates. So the coordinates of a point that lie on this side is going to require an x and a y. So we already know what the y coordinate is, but now we need to find the x coordinate. The x coordinate would be equivalent to this distance here. Now if I take this triangle and I kind of pull it away, and I say that this is 2 and this is 1, knowing that the x and the y directions are at right angles to one another, or perpendicular always, I can figure out the x coordinate here. Okay, and so what I would do is I would use Pythagorean theorem. I would say that 1 squared plus x squared should equal 2 squared. Pythagorean theorem is the two legs squared summed up should equal the hypotenuse squared. And now I can simply solve for x. Solving for x is going to be 1 plus x squared equals 4. I just took care of the squares on the numbers. Now if I subtract 1 from this side and subtract 1 from this side, I'm going to get x squared is equal to 4 minus 1, or 3. And so I can say that the x is equal to plus or minus the square root of 3. And so this distance is the square root of 3. Okay, the square root of 3. Okay, so now if this distance is the square root of 3, that distance is 1, and this distance is 2, then I've satisfied sort of a triangle that that corresponds to the theta, the angle that we're looking for, and the terminal side is going to be one point on that terminal side could be the square root of 3 comma negative 1. And so this point lies here because I know that it satisfies all the conditions. Alright, so that is one of the complex questions. I'll go into another one. If the cotangent of theta is equal to a minus 1 over a plus 1, find the secant of theta. Find the secant of theta. And so, since I know that the cotangent of an angle, I'm just going to use a first quadrant for this question because it doesn't say that I have a specific quadrant here. So what I'm going to do is I'll stay in the first quadrant and I'll say that angle theta, and since I know that the cotangent, this is from this is an equation for cotangent of an angle is equal to the x coordinate over the y coordinate, or you can also think of if you just look at a triangle, it's equal to the adjacent side over the opposite side. And since this is already in fraction form, then this must be the adjacent side of the angle, and this must be the opposite side of the angle. And so I'm just going to write this is a minus 1 and this is a plus 1 because the cotangent of an angle is equal to the adjacent side over the opposite side. So I can set up this triangle. Now I need to find the secant of the angle. Okay? And I know from definition that the secant of an angle is equal to the hypotenuse divided by the adjacent side. But unfortunately I don't know the hypotenuse. I do know the adjacent side, so in the end the secant of this angle is going to be the adjacent side, or a minus 1 over, it's going to equal the hypotenuse over a minus 1, because the adjacent side to theta is a minus 1, And now I have to figure out the hypotenuse. The hypotenuse I can figure out again by using Pythagorean theorem. So we're going to be using a lot of Pythagorean theorem here. I can figure out the hypotenuse by doing a plus 1 squared plus a minus 1 squared. This is the hypotenuse squared. And so if I basically can square root both sides and take this entire thing and place it there. So the secant is equal to a minus 1 over the hypotenuse. But what I'm going to do is I'm going to simplify this down a little bit. A plus 1 squared is a squared plus 2a plus 1. A minus 1 squared is a squared minus 2a plus 1, and this is equal to the hypotenuse squared. What I did is I just foiled this and foiled this, and got these two expressions. Just multiply a plus 1 times a plus 1, and you get this. A minus 1 times a minus 1, you get this. Because remember, squaring something is itself times itself. And so now I notice that I've got an a and an a, one with a 2 and one with a negative 2. So in the end, it's a squared plus a squared, which is 2a squared. And then 1 plus 1 is plus 2. And then this is equal to h squared. I've taken this and simplified it down. And now I just square root both sides. And so h is equal to the square root of 2a squared plus 2. Alright, so 2a squared plus 2 square rooted. This is what the secant of theta is equal to. So, in this question, I tell you that the cotangent of an angle is equal to that divided by that. I know that the cotangent is defined as the adjacent over the opposite. So I say, well, this must be the adjacent, this must be the opposite. Place them there and there. Because that's the adjacent and the opposite, I can find the hypotenuse using that algebra. Now I can find the secant of an angle because I know that the secant is the hypotenuse over the adjacent. And so I find the hypotenuse and place it in the numerator, and I find the adjacent, place it in the denominator, and so this is what the secant of theta is equal to. Alright? Now I'll do the third one. The lengths of triangle PQR are 9, 38, and 41. If, actually this is PRQ. If angle Q is equal to 90 degrees, find the value of the three primary trig functions of angle theta, of the smallest angle. Okay. I think I'll pause the video right here, actually, and then I'll get this in a second, part 2.